Okay, so thank you all again that you arrived here. As the chair of the department, I will not carry words. I will just do my duty as the chair of the session. And I just wanted to take a few words about how structural biology started to go into the AI, and then what are the take-home messages. So I will start with the CASP. So what is the CASP? This is a critical assessment of protein structure prediction. So that was the first competition that was done in a blind way, that structural biologists that actually solve structure does not deposit them, and people can predict, and then we can compare it to structures that are still unknown. Okay, so that started in 1994. It's important to know that that's took 10 years, that's the progress, so this is the target difficulty, this is the accuracy. It took 10 years to get a little bit better, okay? Another 10 years that there was no change almost. So with all the computational ways and all the other things, it still took time. Then in 4 years there was, again, a very good progress, but if you notice, this is finished in 2018. And the reason for that is that then came the AI. Okay, so when we include the AI, okay, so this is the current, and I took it down from the competition, you can see the huge jump. Okay, so from CASP 13, already the 14, and there is what known as a server mode, and without AlphaFold 2, so they can compare it to other prediction methods. And the prediction programs like AI servers like AlphaFold 3 and ESMFold really produce something like, look at very, very good and accurate structures. Okay, so that's where everyone started to do the hype. There is no need more for structural biology. But as you saw from the beginning, it's not really the truth. Okay, so one of the key points is that AI have different ways of calculating things, and structure coming from AlphaFold 3 and ESMFold are not the same. So one first thing, as my own view, is you always need to try, as any other experiment, to try two different methods or two different AI and compare. So if they're not comparing, something is wrong there is the structure, because the real structure will be the same node. So few take-home messages, and I will finish with that. So AI structures are still a prediction. Don't forget that. I know that you go to conferences and people are showing you structures and it's been solved. No, it's not been solved. This is a prediction. Okay, it's good for generating ideas and models, but it needs to be tested with other techniques. Okay, and I know that many people try and they do mutation and they do cross-linking, and then they get different results than the prediction that they produce. One needs to analyze the produced structure. So the fact that the program gave it to you doesn't mean it's real. Okay? Scores may be misleading. So low score doesn't mean a wrong structure, and a high score doesn't mean a real structure. So I saw both cases that are not fitting, and there is also sometimes not a perfect match. Definitely when you go to protein interaction, protein ligand interaction, the errors are starting to increase. Most accuracy seems to be in the backbone. Okay, it was already tested lately that side chains rotamers are less accurate. So for a prediction of drug, this is still an issue, where even a rotation of one atom can make a difference. And people forget, but water molecules, okay, they are part of every single structure that we solve. I see them when I solve them. They are not in the predictions. I'm not sure they didn't been calculated to see how they contribute to the accuracy and the fold of the structure, and that is maybe the future of the rest of the training sessions of AI. So today's session, we will start with Ora Schuler-Fuhrman of the Hebrew University. I will not read now all the titles, but you have them here. I'm sure we're going to have a nice talk from her. Afterwards, followed by Miki Koslow from the University of Haifa, Sarel Fleischman from the Weizmann Institute, and Nir Bental from the Tel Aviv University. And we start this session now. Thank you.